Dear students, welcome to the lecture series on power system analysis. Today we'll be discussing a couple of questions based on the Singh equation which has been asked in your previous university question papers as well as GATE. So this is a previous KTU question paper, question from the KTU question paper. So here the question is to find the energy stored in the rotor of a 3-phase 50 Hz to 50 MVA turbo alternator with H inertia constant equal to 7.5 megajoule per MVA, and you have to determine the inertia constant. The generator is initially supplying a steady state power of 150 megawatt and the mechanical power is input to the turbine is reduced to 100 megawatt. You have to evaluate the initial acceleration of the rotor and neglecting the losses. It's a 6-pole machine, and you also have to find out the rotor speed after 10 cycles. Okay, so the data that is given is initially your machine is delivering 150 megawatt. Input to the mechanical input is 150 megawatt, that is PM1. PM is 150 megawatt, that is equal to PE, that is being delivered because losses are being neglected. Now your mechanical input is reduced, or input to the turbine is reduced to 100 megawatt. So initially you are at 150 megawatt, later you are reducing it to 100 megawatt. So your accelerating power PA will be PM minus PE. Okay, so your Singh equation you know, m into d squared delta by dt squared is equal to PM minus PE, which is equal to PA. Okay, so this PA, accelerating power, is given by PM minus PE. PM is the current operating condition at which your machine is operating, that is 100 megawatt is being provided to the rotor or the turbine, and PE is the electrical output which has not changed, it is still at 150 megawatt. So your PA is minus 50 megawatt, or it is rather a decelerating power because it is having a negative sign. Now the energy stored is given by the equation GH. G is your MVA rating of the machine which is given, and H is inertia constant which is also given, so you will get this value. Now you can calculate your M, moment of inertia, is GH by 190F. Okay, you will be getting this value. Now your acceleration alpha is, this is from your Singh equation, m into d squared delta by dt squared is alpha. Okay, or you can write m alpha equal to PA. Okay, m alpha equal to PA, that is m into d squared delta by dt squared is equal to PA minus PE. So PA is minus 50 and m is already calculated, so you will be getting alpha equal to, or acceleration equal to, this much electrical degree per second squared. So that is deceleration is this, acceleration is negative, so it is a deceleration. Now synchronous speed is calculated. Now your acceleration is in electrical degree per second squared, so you are converting it in mechanical degree per second squared by multiplying with 2 by P. Then you are converting this mechanical degree per second into RPM, mechanical degree per second to rotations per minute, RPM. Okay, so you are multiplying with 60 by 360. Okay, degree you are dividing by 360 and seconds you are dividing by 60 to make it minutes. So you will be getting alpha equal to minus 13.35 RPM per second. So the time corresponding to 10 cycles. So you are asked to find out speed after 10 cycles. So one cycle is 20 milliseconds. The time period for 10 cycle it is 0.2 seconds. That is 200 millisecond or 0.2 seconds. So speed after 10 cycle is given by initial speed ns plus v is equal to ut plus half at. Okay, u plus at. So this is initial speed ns at 1000 rpm, and this is acceleration alpha minus 13.35 and time is 0.2. So you will get your final speed as 997.33 rpm. So once your mechanical input is reduced, your machine will be decelerating and your speed will be reduced from 1000 rpm to 997.3 rpm. So that is the final answer that you get. Now the next is a gate question. I suppose it is from 2017 paper. So this is a three-phase 2-pole 50 Hz synchronous generator with a G of 250 MVA, 0.8 perfect lagging. Kinetic energy is given as 1000 megajoule, and it is delivering 60 megawatt of power at an angle of 10 electrical degrees. So currently your alpha is 10, or alpha 0 is 10, initial angle is 10 degrees, electrical degrees. The load is suddenly removed, assuming the acceleration to be constant. Load is removed in the sense electrical output is reduced to 0 suddenly. Assuming an acceleration is constant for 10 cycles, the value of power angle after 5 cycles. So what will be your alpha after 5 cycles in electrical degrees? So that is what you need to find out. So the value given is kinetic energy. The initial power operating point is 60 megawatt, that is mechanical input equal to electrical output, which is equal to 60 megawatt, and your final output is 0. Okay, and your delta 0, initial angle is 10 electrical degrees, and your time for 5 cycles is 0.1 seconds. 5 into 20 seconds. So you can calculate your M as kinetic energy KE by 180 into kinetic energy by 180F. So you will be getting 1 by 9 megajoule second per electrical degrees. M alpha is equal to PM minus PE, which is PM is initial value as 60, and now your PE has reduced to 0. So that is PM minus PE is 60. Now your alpha will be 60 by M, which will be getting us 540 electrical degree per second square. So your the current value of delta will be given by delta 0 plus half alpha t squared. Delta is equal to delta 0 plus half alpha t squared. So this is a generic equation. So from this you will be getting 10 plus half into alpha is 540 into time is 0.1 squared. So you will be getting 12.7 electrical degree is the current angle at which the machine is operating. That is, your electrical output has reduced. Electrical output has reduced to 0. So your machine will be accelerating because you have a mismatch. You have an accelerating power of 60 megawatt. PA equal to 60 megawatt. So your machine will be accelerating, and since it is a synchronous generator, during acceleration here delta will be tending to increase. So from 10 degree your delta has increased to 12.7 degrees electrical degrees. So this is the answer that you will be getting. So it was a 2 marks question asked, and this particular question for the university was 10 marks question. Okay, and this was a 2 marks question. Okay, so with this I will stop the current lecture. We will meet with a new topic. Thank you.